Okay, so 2.2a, we're going to try to get through half of 2.2. We'll see. Still talking about graphs of polynomial functions. So, what does a graph of a polynomial function look like? Well, first of all, it is continuous. What does that mean?
Negative infinity, positive infinity.
No.
Doesn't stop.
Yeah, it doesn't stop. I can draw it with my pencil without picking my pencil up. What is a function called that is not? It's not broken.
A stair step.
Continuous.
Discrete. Very good. Thank you, Lizzie.
Smart.
All right. So this is a continuous function. A discrete function is something like a step function. Okay? Your greatest integer function is discrete. It's broken. You have to pick your pencil up to write it. So this is continuous, smooth, rounded, never sharp and pointy.
So, like, would you consider?
So would the absolute value
No,
function
that's
be
pointy.
considered? That's exactly
That's what I was
right.
gonna
That's
ask
what I'm
you.
trying to get across to you. Okay? So never sharp and pointy, which I'm not even sure is a word, but whatever. All right, so no, absolute value function is not a polynomial function. Okay? So, degree of the polynomial. All right? How do you tell the degree of the polynomial?
The highest exponent.
The highest exponent. So the biggest exponent, he tells what degree it is. Can't write today. The highest exponent. Okay, so what if the highest exponent is odd? It's called an odd degree function. Now, y'all listen, am I saying that the function is an odd function? No, we've already done that.
The
And how do
degree
you
is
tell if
odd.
something is even or odd? Then you have to do f of negative x and the opposite of f of x and all that stuff. That's not what I'm talking about, okay? So I'm talking about if the highest exponent is an odd, then it is called an odd degree function or polynomial. So, hey, do y'all know any odd people around here?
Yes.
Yes, okay? So everybody knows. So why do you think they're odd?
He has big nose.
Because
Because
he's
they're what?
Korean.
Because
That's special.
They're twin.
They're different. Y'all, they're different than you. Do they think you're odd? Yes, they do. Okay? If you don't know that, if you think they're odd, they think you're odd. Okay. So odd means different. So an odd degree polynomial begins and ends in different directions. Okay? If it's an odd, if his highest exponent is an odd number, I'm talking about a 1. Hello, that's a line, people. Begins and ends in different directions. A 1, a 3, a 5, a 7, whatever. He begins and ends in different directions. Which leads you to believe that an even degree function, what? Yes. Begins and ends in the same direction. Think about a quadratic. That's a second degree function. Okay, he's an even degree function. They either open up, he starts up and ends up, or they open down, starts down and ends down. All right? One more little vocabulary word I need to get out of the way before we do do our little chart, and that is a leading coefficient. Okay? A leading coefficient. What is a leading coefficient?
Number in front of,
Coefficient of the highest exponent.
He is the coefficient of the highest exponent. So I'm calling it a leading coefficient because if your polynomial is in standard form, then he will be the leader. Okay? Do they have to write it in standard form? No, they don't, so just know that the leading coefficient is the coefficient of the highest exponent. Okay, coefficient of the highest exponent. So, now we're gonna make out a chart, all right? I'm gonna talk about odd degree polynomials and even degree polynomials. We're gonna draw some pictures, talk about their end behavior, and list it two different ways. Now, remember on this test, we have part of this test with no calculator, right? That's where you're going to take three equations and you're gonna put them in vertex form. They're gonna call it standard form, all right? And you have to do it without a calculator, and then you're gonna tell me some things about it, like what's the vertex of the parabola? What's the axis of symmetry? Tell me what the roots are, the solutions, the x-intercepts, those are all the same thing, okay? So first I'm gonna talk about the odd degree. Okay, so odd degree, there are two things that can happen. I could have a leading coefficient that is positive, or I could have a leading coefficient that is negative. Okay, so we're gonna talk about what they look like. Now, the sign of the leading coefficient tells where you end up going. Not where you came from, but where you end up going. Alright? So, this positive tells where this graph ends up going. Would that be his left-hand behavior or his right-hand behavior?
Right.
Yeah. Does everybody understand? Where he ends up going, when we read from left to right, this is where he ends up going. So he's gonna end up going up. Since he is an odd degree function, where does he have to come from?
Down.
Down, okay? So he might look like this right here. Now, if his leading coefficient is negative, where does he end up going?
No. Down.
Down, okay? Where did he have come from?
Up.
Up. So he might look like this.
Down looks funny.
Like me.
Okay, shh. How old are y'all?
And
Old enough to know that his nose is abnormally large.
Colton?
It's true.
All right, so here we go. We're gonna talk about end behavior two different ways, okay? We're gonna talk about end behavior two different ways. Now y'all listen, this is gonna be on that first page of your test with no calculator. So you're gonna have to know end behavior without a calculator, all right? So the first way, this is the way it's gonna be on the first part of the test, but then within the test, it's gonna ask you this other way. All right, so the first way is really easy. I'm gonna ask about left hand,
Is this part of the chart or is that?
and yes, it is. And I'm gonna ask about right hand behavior.
I like the negative instead of being.
We're going to do that one, that one's gonna be over here. It's a little more difficult. It's the more technical way to write it. You probably struggled more in Algebra 2 with it. This year, you're gonna be like, whoa, why did I think that was so hard? All right? So it'll be a lot easier. So left hand and right hand. When I ask it this way, left hand and right hand, the words that you use are rises and falls. Okay? Rises and falls. So look at this graph right here. On the left hand side, what would he do?
Rise.
What?
Fall. He's
He-
falling.
No, what's he doing?
He's falling.
He's going down, okay? All right, he's fall. What about the right hand behavior?
Flying.
Yeah, he rises, he goes up. Now, if he's an odd degree function, what do you know about these two words?
Opposite.
Yeah, they're gonna be different, people. They're gonna be different. All right, let's go do this guy over here. We're gonna do left hand. And we're gonna do right hand. Okay? Left hand and right hand. You gotta know your left from your right, people, alright? So, on the left hand behavior, what does he do? Rise. And right hand behavior?
Falls.
Falls.
Do you use the finger trick where it
You
makes an
can,
L?
your left hand makes an L, your right hand does not. Okay? So if you don't know which one is which, you can hold them up and look at them, and people will know that you do not know.
People seriously not know which one is which?
Yes.
Well, if you really think about it, sometimes I don't remember.
It doesn't make a difference.
Oh,
Alright, now let's do it.
Actually right.
Hey, here we go. Here's another, this is another way of saying the same thing, but this is a very technical way. Alright, so pay attention. Now, first of all, let me ask you, f of x is the same thing as y. Which ways can y
Up or down?
go?
Up and down.
Up or down? Up would be approaching what? Positive infinity, and down would be approaching
Negative.
negative infinity. Which way do x's go?
Left and right.
Left or right? Left would be approaching,
Negative infinity.
and right would be approaching.
Positive infinity.
Very good. So that's what we're using, all right? So I'm gonna start off, I'm gonna do the left hand behavior on the left side, and then I'll do the right hand behavior on the right side, okay? So I'll label it the first time, but then after that, I will not label it. There is no reason to label it, people, because the X will tell you which side I'm doing, all right? So here we go. Left-hand side, f of x approaches, that's what that arrow means, approaches. What is the y approaching on the left side of this graph? Negative infinity. As x approaches, what does the x have to approach if you're talking about the left-hand side? Negative infinity. Okay? Looking at the right-hand side. What does f of x approach? As x approaches, very good. Okay? So, y'all look. This right here is what says I'm looking at the left-hand side. As x approaches negative infinity, that's this way, to the left. Okay? This right here says I'm looking at the right-hand side. As x approaches positive infinity, that's going this way, so that's the right-hand side. So I don't have to write left and right. I'm just gonna write this. All right? So now I'm gonna do this one right here. F of x approaches. What? Positive infinity. As x approaches what?
Negative.
Very good. Do y'all remember this from Algebra 2? Remember how hard it was? It's missed a lot on the test and worksheets because kids just don't get it. Let's do this side. F of x approaches what? Negative infinity. As x approaches positive infinity. That's on the right-hand side. This is on the left-hand side.
Whoa, those switched.
Nope. Left, right. All right,
Wait a
so
second. Say that again?
left, right. Left is on the left and right is on the right.
Oh, yeah, it's going up, but then that way.
All right, so now let's do an even one, okay? So these are gonna be the even degree. Okay? So we're gonna have the same thing. We're gonna have a leading coefficient that's positive and a leading coefficient that's negative. All right, leading coefficient that's positive, leading coefficient that's negative. So I'm gonna draw you a graph. A positive one could look like this. I want you to fill in this, left hand and right hand. I want you to do the little guy over here, the technical way of writing it. Okay, what'd you say for his left-hand behavior?
Rises.
What'd you say for his right-hand behavior?
Also rises.
Very good. So over here, you're gonna say f of x approaches positive infinity as x approaches negative infinity. Which side is that, left or right? Very good. X approaching negative infinity is on the left. So now I'm gonna do this side. F of x approaches positive infinity as x approaches positive infinity. Now I'll do one that has a leading coefficient that's negative. He might look like this. You fill these in, left hand, right hand. Now, when you do this on your test, you're not gonna have a picture, you're gonna have an equation, okay? That's what we're fixing to look at in just a second. Okay, over here on the negative coefficient, negative leading coefficient, what is his left-hand behavior? Falls, and his right-hand behavior? Falls also. All right? Over here, f of x approaches negative infinity as x approaches negative infinity. This is on the left. F of x approaches negative infinity as x approaches positive infinity. This is on the right. Colton? Turn your phone off.
Hi, Colton.
Who was it?
Definitely good.
Definitely Bailey. There was potential spam on my watch.
Bailey?
Colton, I think you can take a blame.
I wasn't gonna say anything, I was gonna
It's
go
not
with
my fault that potential spammers are calling me. How's your
Potential
ringer
spam.
on?
fried or grilled.
Good night. All right, so here we go. Example 2.
I had just now turned my phone on silent too, like I literally put on my phone to turn it on silent.
Is it day 2 or day 1? Day 1? Okay. All right. We're fixing to do example 2. Shh.
What?
Okay.
I'm sorry to say this.
Example 2. Tell the left hand and the right hand behavior. All right, tell the left hand and the right hand behavior. And then I'm gonna ask you some other things, okay? We're gonna do it both ways so that we practice both ways, because on the test you will see it both ways. And here's your polynomial. F of x is equal to negative x to the third plus 4x. Negative x to the third plus 4x. So, here's my question. What's the degree of the polynomial?
Odd.
Yeah, but what is it?
Three.
Three, it's a three, a third degree, that's my highest exponent. So it is odd. Everybody ready?
Yes.
The leading coefficient, what's the sign of the leading coefficient? Negative, because it is a -1, all right? So that means, now look, once I do this right here, I just sketch me a little picture and then I don't have to think about it anymore, okay? Odd tells me that he begins and ends in different directions. The leading coefficient negative tells me which hand behavior.
The right one.
The right, where it ends up going in the end. You read from left to right, so that's the right hand behavior. So he ends up going down, where did he have to start?
Left.
Up.
Okay.
Up left.
So, his left hand behavior is what?
Rising.
Rises, very good. His right hand behavior is
Falls.
good.
So you got that from the negative.
Uh-huh, I got it from this. This negative tells me, y'all, the sign of the leading coefficient tells you the right hand behavior. Okay? He always tells you the right hand behavior. You figure out what the left hand is depending on if my function is even or odd. Odd, he's doing something different. Even, he's doing something the same. Okay? Now we're gonna write it the other way. F of x approaches what?
The positive infinity.
Positive infinity. Obviously, I'm talking about this guy right here. So on this side, as x approaches what?
Negative infinity.
Negative infinity. F of x approaches what on the right-hand side?
Positive, negative infinity.
Negative infinity. As x approaches what? Positive infinity. Okay? Here's my next question. I'm not gonna tell you where we're getting this. I just want to, see if you can catch on. At most, how many humps?
Two.
Very good.
One less than the highest exponent, right?
I wonder, do you ever listen? I'm guessing no. Am I guessing right? I said, I'm not gonna tell you how to do this. I'm just gonna let you figure it out.
You're not gonna.
Oh, well
So,
then people said
You're
the
not
answer.
the only person that, I want everybody to figure it
Oh,
out though,
that's my
okay?
fault.
Alright, so here we go. Here's the next one. B, f of x is equal to x to the fourth minus 5x squared plus 4. Here's what I'm gonna wanna know. Left hand behavior. Right hand behavior. All right? Even or odd degree function? Even. He is a fourth degree. Does anybody remember what a fourth degree is called? Quartic. Okay? Even. His leading coefficient, positive or negative? Positive. What does that tell you? What does this positive tell you? Which hand behavior? Right. So the right side is going up. What is the left side doing? Yeah, he's doing the same thing because he's even. All right? So what's my left-hand behavior? What's my right-hand behavior? Are you with me? F of x approaches what? Positive infinity. As x approaches negative infinity, that's on the left. F of x approaches positive infinity as x approaches positive infinity. That's on the right. Okay? At most, how many humps? Very good.
How do you know?
It's one less than than his highest, whatever his degree is. Okay? His highest exponent. How many times does he change directions? Could he change directions? 4. That is the exponent. And those 4 times could make those 3 humps, changing directions. If you change directions, going down, going up, there's that 1 hump. Okay? All right, so here we go. C, last one, f of x is equal to negative x plus x to the 5th. I want to know the same stuff. Left hand and right hand. Okay, ready? What's the degree of my polynomial? 5th, even or odd? What's the sign of the leading coefficient? Very good. See how I flipped that around? Be careful. I call it a leading coefficient because if it's in standard form, starts with the highest exponent and goes down, he is my leading coefficient. He is the leader. All right? But they don't have to write it that way. So the leading coefficient tells the right-hand behavior, so his right-hand behavior goes up. Since he's odd, his left-hand behavior goes down. So this is the way he's going to look on his left end and right hand. Okay? So left hand does what? Falls. And right hand does rises. Anybody got a question? This is what it's going to look like on the test with no calculator. I'll give you a function, and then I'll say, tell me his left hand and right hand behavior. Should y'all be able to do that without a calculator? Yes. Okay? Over here, f of x approaches what? Negative infinity as x approaches negative infinity. F of x approaches positive infinity as x approaches positive infinity. At most, how many humps? 4. Very good. So what about this guy? F of x is equal to x to the 10th. He would have at most how many humps? 9. Do you know how many he has? Yeah, he has 1. He has 1. He looks just like this. He looks very much like a parabola, right? What's different from him from a parabola?
Wider.
Yeah, he's flatter and wider across here. Okay? He's flatter and wider across here. Hey, look, the bigger this number gets, the flatter and wider it gets. Hey, guys, the older you get, the flatter and wider your butt gets. Okay? So you can think about it the same way. It is the same thing. I mean, later this year, when we learn how to graph a parabola, guess what they're gonna have? They're gonna have a line that goes across it like this. You know what it's called? The lattice rectum. I know. You're like, could you not make a better name up? But that's what, it tells how wide that thing is across there, how big its butt is. All right? So, think about that. So what makes all those humps in there?
The second X.
And the third X. All this junk. X to the 10th plus 7x to the 9th minus 6x to the 8th minus 4x to the 7th plus 2x to the 6th. Do you see all that? The more junk you got in there, the more humps you can make in your polynomial. Okay? So that's what makes them. All right. Everybody ready? We're kind of moving on to something else. But, I mean, we're coming back to all that information, you gotta know it. But I want to know what you know about zeros, solutions, roots, x-intercepts, and answers.
They're all the same thing.
Yeah, these are all the same things. These are all different names for the same thing. So I could call them any one of those things and you would need to know what I was talking about. Okay? So, let's see if you can fill out this little chart. These are my roots. These are my factors. Kind of going backwards. Okay, we've made a chart before where I told you the factor and you gave me the root. So now, if I give you the root, can you make the factor? So what if I tell you the root is 2?
X minus 2.
Very good. X minus 2. What if I tell you that the root is 3? X minus 3. So it's whatever you need it to be, right? So then when I set this factor equal to 0 and I solve it, I get x to be 3. So he's always going to change his sign. What about if the root is negative 7?
X plus 7.
X plus 7. Very good. What about if the root is a?
X minus A.
X minus a. What about if it's 3 halves?
X minus.
Nope, no fractions.
Oh, yeah.
Say it, Simon.
Tell me how.
Simon said it. She said it's like 2x minus 3. Okay? If you set this equal to 0, you would add 3 to both sides. That's where I get this number up here. And then you would divide by 2, and that's why the 2 is the denominator. So this number over here becomes your numerator. You still change the sign, and then the coefficient of the x becomes your denominator. Everybody okay? All right, so here we go. We're going to do 2 more examples. So the next one is example 3. What time's the bell ring? 50? Okay. Example 3. We are going to find all the zeros of the polynomial. All the zeros of the polynomial. So we're going to do it right now. We're going to factor this guy. Okay? We're going to factor him. So f of x is equal to x to the 3rd minus x squared minus 2x. X to the 3rd minus x squared minus 2x. Now, I'm going to ask you some questions and see if you remember some stuff from algebra. Okay? How many solutions does this guy have? 3. How do you know that? That's my highest exponent, right? My highest exponent is 3. So the fundamental theorem of algebra, Freddie Goss discovered that long, long time ago, says that if whatever the highest exponent is, whatever the degree of the polynomial, that's how many solutions I will have. Okay? So let's set him equal to 0. Remember that y, that's what this is, and 0 are interchangeable. And let's factoring. What's the first thing you say to yourself when you're factoring?
Take an X out.
Yeah.
Is there
Can you
anything-
take anything out? And yes, and X pulls out. What do you multiply X by to get X to the third? What do you multiply X by to get negative X squared? And what do you multiply X by to get negative 2X? Now we're gonna try and factor this guy. What does X squared factor into? X and X. What's a minus sign at the end mean? Yeah, so one's a plus and one's a minus. The factors of 2 are just 1 and 2. Do they subtract to be 1? Yes. Remember that if this coefficient of the x squared is a 1, that this cheater sign right here tells you, hey, the factors of this guy that subtract to be this guy, okay? You can just look at it that way. So I want a negative 1, so who goes by the minus sign? And the 1 goes here. If you're not a good factor, you should always check your inners and outers. So there's a plus 1x, and here is a negative 2x. And there's my negative x that I'm looking for that middle term. Okay? Now, x minus 2 is the factor, guys. What's the 0?
2.
2.
X plus 1 is the factor. What's the 0? What about this guy right here? Yeah, how did you get these things? Well, you set them equal to 0 and solve for x. So when I set this guy equal to 0, guess what? It just looks like x equals 0. There's nothing to solve. So that guy is 0. So there's my 3 solutions. Okay? Now watch this. I'm going to graph this guy. No calculator, people, right now. All right? So he has zeros. That means my graph crosses the x-axis at negative 1, 0, and 2. Does everybody agree with that? Negative 1, 0, and 2. Okay? Let's talk about this function. Is this an even degree or odd degree?
Odd.
Okay, so he's odd degree function. Tell me what his leading coefficient is, positive or negative? So that means he ends up on the right going, and he had to begin.
Going down.
So that means over here at negative 1 on the left, he's going down. And then he crosses at negative 1, and I don't really know how high he goes up. But I do know what?
He comes back down.
He comes back down and he hits 0 and crosses at 0. And then again, I don't know how low he goes, all right? But he comes back up and hits 2 and crosses and keeps going up. Do we know that much about my function?
Yeah.
Now all we'd have to do is like make us out a little t-chart, right? I would probably pick a number in between negative 1 and 0, like negative 1/2. I would plug it in my equation and find out how high it went. And then I would pick a number like 1. I would plug it in my polynomial and see how low it goes. Could you do that? Okay, so we're moving on. I'm gonna say you can do that, all right? Example 4, y'all listen to me. I'm gonna give you a 50-point test and you're gonna have to do that, okay? Are those gonna be pretty numbers?
No.
They're not, y'all. They're not gonna be pretty numbers. Is that gonna make you make an F on the test if you can't figure that out? No. Will it keep you from making 100? Yes, it will, okay? But it's not gonna, you're not gonna lose that many points.
What's not gonna be pretty numbers?
When like if I wanted to know how high that went and I didn't have a calculator, I would pick something in the middle like negative 1/2.
Oh, okay.
And I'd give me a T-chart. And I'd plug that negative 1/2. You can plug it in this down here or this up here, they're both the same thing. Okay? And then I would plug in 1 because he's in the middle. And I would find, that would tell it to me. Alright? I'm not gonna take the time to do it. Alright, so here we go. Example 4. But on the 50-point, you will have a 50-point test on what we're getting into, and that will be one of the skills that I will require. Okay? So you are going to find all zeros and relative extrema. What's he talking about? Mins and maxes. He's talking about relative, like, would this be a relative max right here somewhere? Would this be a relative min here somewhere? Now, if he's asking me to find those, what am I gonna have to use? A calculator, okay? But I'm only gonna use my calculator for this right here, all right? I'm not gonna use it for anything else. Here's my polynomial. F of x is equal to negative 2x to the fourth plus 2x squared. Okay? I know I'm gonna graph it, so I'm just gonna go ahead and draw me a graph. Okay, so let's start right here. What are we gonna do first?
Take out the negative.
Yeah, see what I can take out. What are you gonna take out?
Negative x squared.
Negative 2x squared, okay? Now y'all listen to me. If this first term is negative, then I'm pulling a negative out. If the first term is not negative, I'm not gonna pull a negative out, okay? My algebra kids are struggling with that. Like sometimes they pull out a negative and I'm like, why did you do that? I mean, you still can work the problem, but it does look a little funky and it's not what you're accustomed to. So I would say don't pull a negative out unless it's that first term, okay? So I am gonna pull a negative 2 and everybody's got an x squared. What do you multiply negative 2x squared by to get negative 2x to the fourth?
X squared.
What do you multiply negative 2x squared by to get positive 2x squared?
Negative 1.
Now what do you know about this guy right here?
That's fine.
What's the difference of two?
Yeah,
plus
difference of
x
two
plus
perfect squares. So negative 2x squared, what does he factor into?
X plus 1 is.
Yes, x plus 1, x minus 1. Conjugates. Square root of the first plus the square root of the second, and square root of the first minus square root of the second. All right, so let's talk about my zeros. What's this guy's zeros?
1.
What's this guy's zeros?
Negative.
How many do I have?
3. 4.
4. You're supposed to have 4 of them, okay? So what about this guy?
It's gonna be plus or minus.
Negative 2x squared equals 0.
Is it plus or minus 2?
Plus or minus 0? Is there such thing as
No.
plus or minus 0? So x squared is equal to 0? Could I write that like this? X times x equals 0?
Yeah.
Now which one's what? They're both what? 0. So how many times does 0 occur? Twice. What do we call that? A double root. So we put a little dr. So this is 2, and there's 3, and there's 4. All right? We're going to graph them, and then we're going to stop. So at negative 1, at 0, and at positive 1. And we're going to stop right there. Okay? Anybody got a question?